All right, so we're back again, and now we're going to go through the lesson of 6.5, and it's called, what is it called again? Measured reasoning, and we're going to be able to practice using geometric reasoning through computational work, right? How do I look for structure in a diagram so I can use familiar features of the diagram to find the measures of unknown sides and angles? What measurements do I need to calculate first in order to calculate additional measurements? Sorry, we're still getting over this. So whenever we're doing these types of problems, they look always very busy. Okay, so just keep that in mind. So it says in the diagram, lines P, Q, R, and S are parallel. Find the measures of all missing sides and angles by using geometric reasoning, not rulers and protractors. If you think a measurement is impossible to find, identify what information you are missing. So here's our first diagram, and it looks like a big mess. Okay, it looks like a big mess. So what I need you to do is find something that you're comfortable with and then start there. Okay, so again, find something that you're comfortable with and start there. And when I say that you're comfortable with, it's something that you know a lot about. Okay, so find a shape, find some stuff that you know, and then that's going to help you find all the rest of the information. Okay, so I'm going to go back to the original instructions. It said that P, Q, R, and S are all parallel. Okay, they're all parallel. So that should make your brain go like, oh, because they're parallel, I get all kinds of angles being congruent and stuff like that. Truth, right? All right, so first of all, I'm going to label these all as parallel by using my little arrowhead here. That's going to help me. And I see other shapes that I can start with, but because they first told me it's parallel, I'm going to go find all my things that are parallel. So I'm going to start with P and Q. So when I look at my parallel lines, I'm only looking at P and Q, and I'm going to pick a transversal to work with. Okay, and then I'm going to use two others, and I'm going to slowly go through and find all of them. Okay, so I'm going to talk my way through all of this so that you're not lost. So if those two pink lines are my parallel lines, I'm going to use this yellow line as my transversal. And then you should remember all of these types of angles that are congruent, and even other angles too. So let's see. Because I know that this angle here is alternate interior to this angle here, I know that that angle is also 33.7 degrees. So I'm going to undo that and just write 33.7 degrees. And I'm going to mark this like this just so you can see it. Is that okay? It's going to get a little messy, and you're just going to kind of be okay with it for now. All right. Do you see any other angles that you can mark based on that? You can find based on just that simple diagram. So when I want you to focus on this, I almost want you to look at it like this and ignore everything else. You should be ignoring this line right here, this blue line. If I extended it, you should be ignoring that. You should be ignoring this. You should be ignoring all those numbers, 4, 3, 12, 12, and 21.6 and 10. Ignore all of it. So maybe you saw that because this is 33.7 degrees here, this angle in here is 33.7 degrees. You know the other side of that angle because they make 180, right? So because I don't want to make a mistake, I am going to use Desmos because I don't want to have to go back and fix. So 180 minus 33.7. Oops, I didn't get 33.7 there. 33.7 is 146.3. So I found that this angle here is 146.3 degrees. Okay. So now that you've seen me do that, I can also go with this other, green angle over here, but that's going to be a little bit too messy. So maybe I'll bring that in later. Maybe I'll bring that guy in later. So because of that, I'm going to erase a couple things to make my diagram a little neater. I'm now going to switch my parallel lines, okay? So I'm going to erase that pink, and I'm going to choose another line to talk about. So I'm going to use this line here. And I want you to find all the like stuff that you can get because those two lines are parallel. Now, before we move on, I forgot that we can also do the angles above. So I'm going to write those in as well. So because these two angles right here and here, this one and this one, they're called vertical angles. So I'm going to write this as 33.7 degrees as well, right? And because the 146.3 is vertical to this one, this is also 146.3 degrees as well, right? Now, if you're really trying to be a boss here, look at this 33.7. Who is he vertical to? Who is he vertical to? And hopefully you said this one right here because it's quite a mess. So I want to make sure that you see who's 33.7 equal to. And I'm going to try to keep all the angles that are the same in the same color. That way you can kind of like track all the samies, right? You want to look for all the twinsies, right? Okay, so now going back to my parallel lines P and R, the two pink lines that I have highlighted now, which angles do you see are parallel now? I mean, which angles do you see that have a relationship? And then you're like, oh, I see alternate interior angles again. And you're right. It's right here again, right? So again, this guy again is going to be 33.7 degrees. It's okay if your writing gets a little bit, into other things. That's fine for now. Okay. Do you see anything else? What else do you see from that information? And now, yeah, you're right. Now that you know that 33.7 degrees is there, now you know that this is 33.7 because those two angles, this angle here and this angle here, are vertical angles. So this is also 33.7 degrees. So do you see how it becomes a little bit more manageable as you practice all of these things? Okay. So far, just off to the side, things that we've used is alternate interior angles when you have parallel lines. We've also used supplementary. And if you don't remember supplementary, no problem. I'll write a little hint for you. It's two angles that add up to 180. So I'll write two angles whose sum is 180. And the last one that we've used so far is vertical angles. Okay. All right. So there goes that. So let's find some more information. I think I'm done with those two lines being parallel. So I can label all those other little, like the bigger angle in there, the green, think about that green angle. So if you think about this, let me go back here. I'm going to mark all the green angles just so I can reference them later maybe. So this is going to be congruent. This is going to be congruent. This is going to be, these are all 146.3. And maybe that's how I'll mark it right now. Those are all 146.3. So if you think about it, we're also now using corresponding angles. And corresponding angles, I will draw you a little picture. Looks like this, where this angle corresponds to this angle. They sit in the same seat. That's how I've described it before. And I should have drawn alternate interior angles like this, right? This guy and this guy. Oops, that's not helpful. Let me try again. Okay, so I want you to look at this. I'm going to erase the pink line, and I want you to think, okay, so I'm going to go with the next pink line, right? This guy down here. And I want you to think about what information what am I already going to write? So go ahead and do that, pause, and I'll come back to me and we'll check if you got it, if there's anything that you can write. Okay, so now that you've checked and you've looked for more angles um, with our line S and our line P, I'm sure you saw that this one down here would be 33.7 degrees, and same with this one. Now, again, you could be using corresponding angles, alternate interior angles. Either way, it doesn't matter. And then again, you would have seen that you had that 146.3 again follow all the way through. But because there's no other angles that are cutting this angle, this green angle up right here, I'm just going to actually write in 146.3. All right. So now we have a bunch of angles along here. So now, because I've used all of my parallel lines with this yellow line, I'm now going to change my transversal. So I'm going to change this transversal, and I'm going to use this transversal instead. It doesn't matter which one you use. I'm just going to pick the next one, which for me, the next one is this one. Right? So now what I want you to do is I want you to find all the stuff that would match this one. So because this one is my pink one and my pink one, I'm going to keep this, I'll keep this. So here I have some 53 degrees here. I want you to find me all the places that you can match them up. I don't know if you notice here, but every single time I got a parallel line, I got the same numbers sitting in the same seats, right? That means corresponding. So go ahead and fill out these numbers here. And you should have said, hey, Miss Johnson, I would have seen that this is 53 degrees right here. Exactly, because of vertical angles. And then if you look here, because I have this parallel line with this parallel line, I would get alternate interior angles with this. So I'm going to write 53 degrees here. Right? And again, by vertical angles, I got this guy up here, 53 degrees. This is where it gets a little bit like squishy because, Miss Johnson, she writes very big and this space is very small. So just keep that in mind. All right, so what else can we find? Do you see any other angles that you can find from here? And some of you are saying, Miss Johnson, we could talk about the linear, right? The linear pair. And you're right, right? So this would be 180 minus 53. Let's see. 180 minus 50 would be 130, and then take away 3 more, so that's 127. So this angle in here is going to be 127. Let me use a different color. Maybe this one. I think this one would be good. So this is going to be 127 degrees. And so because that one is, then the vertical to that is going to be 127 degrees. Let's see. And then now you know these two. So I'll do that too. 127 degrees. And I think that's all I got from there. Okay. So I'm going to erase this pink line and highlight the next one up just so you guys can do the next one. While I'm highlighting, go ahead and look what angles do I already know because I have that. And you're like, oh, that 53 degrees, Miss Johnson, this one is alternate interior to this one. That's right. So go ahead and fill all them out and then come back to me when you're done. And let's see if we can get all of them in there. Okay, so now that you're back, I'm using 53 and I should not be using that black color because that was 37 degrees. Okay, let me try to erase. Let me see. Let me undo. Yeesh. I think I'm going to undo. Yeah, sorry. I'm going to undo because I want to get that to be a different color. You guys are like, Miss Johnson, really? It's just going to come out cleaner, so that's the only reason why I want to do it. All right, so this line here, I'm going to use blue for 53 degrees. And we already went through this, so I'm going to write it in there. Right? And then I'm going to keep with that pink for 127. And 127 degrees. All right, and then I'm going to move on to the next parallel line That's this guy here. And you're like, oh, I see it again, the 53 and the 127. Very good. So you would have seen this is 53. This is 53. And then your 127 is a little, I only get 127, right? Because that other one, this one here, is going to be 127 all the way across. And I don't want to like make it all messy. So I'm going to wait till we know more angles and then I'll do that. Okay, so I'm going to continue on. So I'm going to go to my next parallel line and it's peak. And you should see a couple more angles in there. And now I do. So I see that 53 degrees, but I'm going to erase that green arc there. So because I know that 53 degrees, and I know that this whole thing makes up 146.3, I can basically subtract it. Another way you can know that is because this is 33.7 and this is 53, the rest of this angle here will make up this line. So we're going to subtract it from there. So I am going to use Desmos because I don't want to make a mistake. Come on, Desmos. There it goes. So there it is again. Here's 180 minus 33.7. There's my 146.3. So I'm going to subtract again 53 and I get 93.3. So 93.3 is that angle in there. So I just need a different color and we're going to use this one. Hopefully you see that's 93.3. And now you know that the other guy, the vertical angle to that is 93.3 as well. So I can erase that green arc right there. So then I'm going to write 93.3 here. And then now you notice, oh, this is 53 degrees. So you're kind of seeing how we go about this, right? So yes, let's see, is there anything else that I could do with this pink line? And the answer is no. So I'm going to erase that. And then I'm going to, oops, I didn't mean to erase that one. So let me draw that one back in. And then I'm going to use our last transversal, which is this guy here. He looks like he's a little perpendicular, and we actually see that he is. Down here, it's showing us that he's perpendicular. So now you can kind of use all of that information to find more things, right? Right. And some of you are thinking, Ms. Johnson, don't we know that this is 93.3? We don't, because we have no parallel lines. So we can't assume that yet. So, okay, because now I'm going to start with not this one. I'm going to start with this bottom one because this bottom one has information that I'm going to use. So I'm going to use the top one with this one, right? And so because this is a 90-degree angle here, I have all kinds of information that I know. That basically means all four angles are right angles. So I am going to use, what color? I'll use gold. I don't know, because that's what I have left. So I draw little right angle marks on each one. So that means I can draw little right angle marks here as well. This is going to look all glittery and funny. Okay, I don't know if you guys can see that, but there you go, right? And so now you can know that these are going to be right angles too because of using this parallel line. So I'm not even going to bother highlighting this parallel line. I'm just going to show those are right angles. I'm going to erase my green arcs right here so I can get to these ones right here. And again, I still have right angles here and here. And so now I want to know, how can I get to this other angle right here? How can I get that? Now, maybe you see this as, oh, this together, they add up to 90. So you would just subtract, and you're right. So I'm going to go use my calculator again and do 90 minus 33.7, and I get 56.3. So that's going to be, let's see, this guy maybe? What did I say? I got rid of him too soon. 56.3. Okay. So that's 56 point. It's still the same color. What color was I going to use? I was going to use, oh no, that was the color I chose. 56.3 degrees. So again, vertical to that, I don't know if you see, vertical to that is going to be this guy. You can kind of see how they point at each other, right? So yeah, that's 56.3 degrees. It's kind of small to write in there, so I got in there no matter what. Okay, let's see what else we know. Okay, so now that I have this right angle, I can also write that this is a right angle as well. So I'm going to use that gold color. Oh, and then, okay, so there's more, right? Do you see this rectangle right here? This rectangle right here tells me that this is going to be 90 as well. And now I'm missing this angle in here. Now there's several ways for you to get this angle. You can actually see this triangle right here. This triangle right here would be a right triangle. So I would add these up and then subtract from 180 to get this one. So what is that? 90 plus 53 is 143. 143, so what would that? 37? 37 to get to 180. So that's 37. I need another color. I think I've used all my colors. Okay, I have these random like colorful colors. I'll do this. 37 degrees. This is like it's my like nighttime pen. See? Or like it's like what is it called? Like a night sky pen. So it's 37 degrees. So I think I'm almost finished with all my angles. Oh, there's an angle up here, which now you can see that's 37 degrees also, because these two lines are parallel. And some of you already know why they're parallel. If you don't know, that's okay. That's 37 as well. So means that's 37 up here. And if you go a supplement to that right here, right, that would be that 143 again. So this would be 143 degrees. I call this one my crayon, right? I think we got all the angles. I can't see any angles that don't have a marking. Okay, so there goes all the angles. We did it. Okay, and these are all the rules that we use. We use alternate interior angles, supplementary angles, vertical angles, and corresponding angles. If you're not comfortable with any of them, make sure that you go over it enough so that it makes sense. All right, so this next part here, now we're going to use the sides in order to find the, we're going to use the numbers that they gave us in order to find more numbers. So the first thing that I noticed is this is a rectangle, and we said it earlier. And because this side is 12, it tells me this side is 12. Okay. And because I want all the numbers to stick out, I'm going to make them black. Or maybe, let's see, what color can I make them? I'm just going to leave it as black. And similarly, I can make this 18 because the opposite side is 18. Okay. And now I see this is a right triangle. And whenever you have a right triangle, your brain should say, oh, I could use the Pythagorean theorem. So I'm going to add this to my list. Okay. So then that means I could figure out this triangle right here. Do you see this right triangle right here? It's right here. So if this side's 9 and that side's 12, excuse me, I can use 9 squared plus 12 squared equals c squared. So what is that? 81 plus 144 is 225. I think that's 15 squared. So that's 15. Oops, that should say c squared. Okay. And let's see, is there any other information that we know? Oh, this is a right triangle right here. But the only thing is, excuse me, I only have one side. So that doesn't help me. I do see this. Do you see this triangle? Here, let me highlight it in blue maybe. Let me erase my pink. Maybe that'll help you see it better. Okay, so if you see this blue, you see this blue triangle, right? And we have a line that's parallel to it. And we know they're parallel because that's what they gave us. So that means we get those proportions, right? So we get this 10 over 15 equals to, oh man, we don't have anything here. But we can figure out this side because we can do this triangle over the big triangle. So if you, in case you don't see what I'm seeing, I'm going to take that little triangle and put it over that big triangle, right? And so this smaller triangle is the 10 and the 18. Do you all see that smaller triangle right here? Is right here. And this side here, well, that's 10 plus 15, that's 25. And this side here, we're missing. We're missing this guy. So we're going to write a proportion that looks like this. 10 over 18 equals to 20. Wait. Oh, you could do it this way. 10 over 18. So left side of small over bottom side of small, right? Is going to be left side of big over small side of big. But we know that this bigger side here is 9 plus 18 plus I don't know. So that's over 27 plus x. And then, so to solve this problem, there's a couple different ways to do it. One of the ways your teacher taught you cross multiply, maybe. Another way is to multiply by the denominators. I first see that this fraction could be simplified. So I'm going to simplify that. So that would be 5 over 9. And I like that fraction better because it's smaller. I like that fraction better because it's smaller. And so now what I want to do is I want to play who's missing. So 5 times what gives you 25? And you're like, oh, it's times 5. And exactly. So in fraction land, whenever you multiply by the top by 5, you're going to multiply the bottom by 5 as well. So your equation looks like, 5 times 5 is 25. Yay, we're done. This one is 9 times 5 is equal to 27 plus x. And so that's 45 equals to 27 plus x. So that must mean that x is equal to 8, or this guy right here. Where did he go? Equals to 18. This guy here equals to 18. Okay. Which means this guy equals to 15, right? Because this just matches this 12. Oh, no. I don't know what I was thinking. So now I have to multiply this, and I'm going to use the Pythagorean theorem. So I got 12 squared plus 18 squared equals to, I don't know, squared. So I get 144 plus, I don't know what 18 squared is. Hold on. Oops. So 18 squared plus 12 squared is 468. And if we square rooted square root 468, oh, it's a number. So we'll just leave that as square root of 468. Okay. So there's a couple more that we can find. Okay, up here in this small triangle here, you have this side being 3 and 4. And again, if you use your Pythagorean theorem, you get 3 squared plus 4 squared equals what squared? So that's 9 plus 16 equals to what squared? So that's 25 equals to what squared? And then 5 equals to question mark, right? So this is going to be my 5 right here. And then now you can also figure out this side here because of this triangle here, right? So that one's going to look like 5 over, I don't know, equals to 4 over 12. So 5 over, I don't know, and then 4 over 12. So then we can cross multiply. We get 60 equals to 4x. That means x is equal to 15. So this right here is 15. Okay, is there anything else that I missed? Okay, so there's a lot to this problem. There was a lot. There was AIA, supplementary, vertical, corresponding Pythagorean theorem. So now I want you identify all triangles in the diagram. Do you know they are similar by dilation or similarity? So go ahead and do that part really quick. So again, the number 2 is asking identify all similar triangles, and then you're looking for those triangles, and you notice that there's a bunch of them that are similar, right? I found this big one right here, and then this little one, or this medium one. Okay, so there's a bunch of them. It's okay to list a couple of them and then come back and see. It looks like quite a mess, right? So just keep that in mind. So here's the same exact drawing. So here, this one says identify at least 3 different quadrilaterals in the diagram. So 3 different quadrilaterals in the diagram. So yeah, you could have said, oh, there's this rectangle. You could have said, there's a trapezoid right here. Okay. There's 2 trapezoids actually. I don't know if you saw this, but this littler one is a trapezoid, and so is this bigger one. So there's a lot of them. Okay. Find the sum of the interior angles for each quadrilateral. So we could do that over here. Looking at all the quadrilaterals, what's the sum of the interior angles of a quadrilateral? So for a triangle, it's 360. I mean, for a triangle, it's 180. And all quadrilaterals, Miss Johnson? Yeah. And then you're like, well, if I look at a rectangle, it's just 4 times 90. So would it be 360? And the answer is yes. Okay. Make a conjecture about the sum of the interior angles of a quadrilateral. So maybe you said the sum of the interior angles of a quad is 360, and that'd be right. So this one says now identify 3 different pentagons. So pentagon is just a 5-sided shape. So maybe you saw this one. Right? So find me another pentagon. There's a couple of them. Find the sum of the measures of the interior angles of a polygon. And for this one, you can kind of see it, right? You can kind of see this triangle here on top of the rectangle here. And so if you were to guess, you can actually go, it's that rectangle plus the triangle. So that's 360 plus 180 is 540, and you'd be right. So make a conjecture of the sum of the interior angles of a pentagon. It's and so another way for you to look at it is if you have a pentagon like this, the sum of the measures of the interior angles of this polygon looks like this. Okay. Oops. So when you're adding all these up, okay, that's what they're asking when you add all them up. And so now you have 540, and you're wondering, oh, well, will all of them be 540? And so I want to go back to our jump start, right? And our jump start told us to pick a vertex and draw all the angles from there. And what do you see here? And you're like, I see diagonals. Okay, but what shapes do you see? And you're like, oh, I see 3 triangles. Yeah. And so 3 triangles, 3 times 180, guess what that equals to? Yep, 540. So there goes your the conjecture about the pentagons is going to be 3 times 180. And then do you see a pattern of the sum of the angles of a polygon as the number of sides increases? If so, write a conjecture. So it's going to be based on this guy. And this is where I'm going to kind of leave you hanging a little bit. And we'll talk about it in the next, when we see each other. So that way I'm not giving away anything too soon. Okay. Let's go over our takeaways to make sure that we're all ready for those. Okay. And oops, where did my takeaways go? All right, here goes our takeaways. It says using the theorem that the sum of the interior angles of is 180, we were able to find the formula. And they give you a formula. And this is why it's true, right? This theorem is both for convex and concave polygons. A concave polygon, so a convex polygon is what you're used to. They look like this, right? A concave polygon looks like this. And do you see the difference between these two? So a concave polygon, I just think about a cave. Do you see how it says cave? You see how it has a little tiny space for you to stay in from the rain outside? And you're like, yeah. So that's a concave. So finding missing sides and angles in a complex diagram requires that I look for the structure in the diagram. Some of the geometric structures I used today were all the ones that we talked about earlier, right? The only one that we would add, and I don't think I wrote this one down, was that side splitter. Was the side splitter theorem, where if you have a triangle and you have a side, then we get it's parallel, and then these are all proportional, right? You get a whole bunch of proportions from them. So what I want you to think is when you're doing these crazy looking problems like this, I don't want you to look at the whole thing. Just like we did, I want you to take two parallel lines at a time. I want you to take one shape at a time or whatever. All right, I hope that makes sense. Have a great day.